Thank you all for standing by and welcome to today's webinar, HashiCorp Terraform to Provision and Manage your Oracle Cloud. Please feel free to share or type your questions during the webinar. This webinar is being recorded and the recording will be made available after post-processing, usually within 2 days. Our speakers today will be Matthew Frary, Ecosystem Engineer from HashiCorp, and Stephen Cross, Director of Partner Business Development from Oracle. And now, let's get started.
Hello, my name is Matthew Frary, and I'm on the Terraform ecosystem team. I just want to give a brief overview of Terraform and some of the challenges that it's trying to solve. So Terraform is an infrastructure management tool whose main goal is exactly what's on this slide. Any infrastructure, any application, anywhere. These are fairly broad statements, and I just want to talk about a few of the challenges that we have to overcome to make this happen. And so the first challenge is heterogeneity. And this boils down to how diverse the cloud provider space is. There are so many cloud options out there and each provides their own benefits. But as a cloud user, you have to decide which is best for you on top of learning their GUIs, provisioning styles, and best practices. This has a very steep learning curve and it only gets worse as you go to multiple clouds. The second challenge is scale. An operator has the ability to scale up and down their infrastructure to suit the needs of the business, but to do this in a repeatable and consistent manner can be a daunting and time-consuming task. And the last challenge I want to address is the ability to enable developers, and this is just looking to cut down the time between a developer requesting resources and receiving those resources. We also want to give them the tools they need to focus on the development work and not the infrastructure needed to do that work. So with those challenges in mind, let's jump into how Terraform manages these challenges, starting with heterogeneity. Terraform is aiming to give operators a single workflow to provision and manage their infrastructure no matter which cloud they're running on. If it has an API, Terraform can manage it. Right now, Terraform supports the majority of cloud offerings through open source Terraform providers. The last time I checked, there were about 75 providers that HashiCorp has an active hand in and about 30 that are community driven. These range from the more standard major cloud providers like the Oracle Cloud that we're talking about today, Alibaba, VMware, others, and then some that are not so much about provisioning infrastructure, but more about helping that infrastructure run, like Datadog and GitHub. Terraform also has a diverse and active community of over 1,000 contributors. This really makes the engine of Terraform run so smooth. Whether there are new features, issues, or cloud offerings, the community is always looking to expand our breadth in that cloud space. Also, if the resources providers aren't supporting exactly what you need, there's always the option to roll your own provider. And contribute that back to Terraform. We're actively working on releasing a guide to do just that with best practices and pitfalls you might hit. The other piece I'd like to hit on is the fact that Terraform allows you to safely provision and change infrastructure with confidence. By running Terraform plan against your configuration files, you can see exactly how Terraform will create, modify, or destroy your infrastructure down to the exact attributes that are forcing those changes. This plan can then be saved and executed in a following Terraform apply that will change your infrastructure as it said it would in the plan. Terraform also manages dependent resources for you. The operator doesn't have to do any manual work to say that two resources are linked or declare that those resources have to be provisioned in a specific order. Terraform does this and can even show you in a resource graph how every resource is related. Moving on to the second challenge, I'd like to address how Terraform handles scale by treating infrastructure as code. And by treating infrastructure as code, Terraform can automate the provisioning of thousands of resources at a time, and in turn, that same configuration can be run consistently, and you know it will do the same thing every time. Terraform also has the concept of state files. These state files represent what the current state of your infrastructure looks like and provides additional details such as IP addresses or open ports that can be teased out and used in other configuration files or tools in your workflow. These state and configuration files can then be versioned so you have a record of what your infrastructure looks like at a specific date. And again, I want to hit on that Terraform is backed by thousands of contributors that are working towards maintaining that human-readable, declarative, immutable, stateful, and multi-cloud qualities that make Terraform the best in-class infrastructure as code tool. The last challenge we want to hit on is how Terraform enables the developer to provision the cloud services they need when they need them. It does this by providing modules which are reusable Terraform configurations that can be used and tweaked to provision exactly the type of infrastructure that the developer needs. What's more is that operators can publish and version these modules to a service catalog called the Terraform Module Registry and point developers to exactly the thing that they need to continue to do their job. In addition, we have hundreds of modules that were crafted straight from the cloud providers. So you know that you're getting the best practices that you need around that certain cloud. These modules can then be combined and tweaked to allow users to provision complex infrastructure without knowing the nitty-gritty details of each specific cloud. So those last three challenges around heterogeneity, scaling, and developer enablement are all handled by the open source version of Terraform, which is great for individuals. But as Terraform becomes a more integral part of your organization, I'd like to talk about how Terraform Enterprise can handle more organizational challenges such as provisioning, collaboration, and governance. The first challenge Terraform Enterprise helps address is by giving teams of operators the workflows necessary to provision with peace of mind. Each team within an organization can have their own workspace where they can keep their work separate from other teams. In these workspaces, you can decide what team members have what ownership, and you know that this is all kept within the purview of your team's workspace. For example, the storage team won't be able to override the virtual machine team's infrastructure accidentally or vice versa. All this is handled through a GUI-based workflow where you can view, track, and execute infrastructure changes. These configurations can also be put into modules, but if you don't want those modules to be made public. And this brings us to the second challenge around collaboration. There's a good chance that the modules you write will be useful across teams, but those modules could have company secrets or best practices specific to your company that you don't want made public. These modules, instead of being published on the public Terraform module registry, can instead be published on Terraform Enterprise's private version of the module registry. Here, the infrastructure experts at your organization are the ones building these modules, so any developer looking to get those modules spun up shouldn't need to configure anything and should just work out of the box. This is also all API driven, so it integrates with whatever CI/CD workflow your organization may have as well. And the last challenge I like to touch on is around governance. Similarly to infrastructure as code, we have Sentinel policy as code, where we can define our policies around infrastructure provisioning in a similar fashion to how we define infrastructure. In this way, they can be checked into version control and embedded into whatever existing provisioning workflows you already have. Whenever infrastructure is looking to be changed, Sentinel checks the existing policies before any changes have been submitted and prevents provisioning if a policy is broken. This is particularly useful when someone wants to change production infrastructure on a Friday at 5 p.m. or provision infrastructure in a region that isn't supported due to data sovereignty. These can be treated as hard mandatory stops where you either have to wait until Monday or swap to a region that is supported. There are also soft mandatory stops where you can get approval to go ahead with those infrastructure changes by someone with that level of access. We don't want Sentinel to stop you from doing your job, but instead to promote best practices at your organization around infrastructure provisioning. Just to recap, organizations that are using Terraform Enterprise are aiming to make their operations teams more efficient. They're trying to enable the developers through self-service workflow. And as they continue to scale, they're trying to govern their workflow to enable best practices while provisioning their infrastructure. The last thing I'd like to touch on is the Terraform ecosystem. Terraform is split into two camps. Core, which is our version control system, such as GitHub and Bitbucket. And this is where we house our infrastructure as code, which allows us to version, validate, and store our Terraform files. On the other hand, we have the infrastructure providers that are managing the resources on specific clouds. Here, we have core partnerships with Oracle, GCP, Azure, Alibaba, Azure, AWS, and VMware, and more. There are also 70 plus other providers that we manage, and those can be found at terraform.io/docs/providers. This list is constantly growing, whether it be with new providers or enhancements to existing providers. So we know that we provide the most coverage across all cloud platforms. And with that, I'd like to pass it over to Stephen to talk about the latest provider that manages Oracle Platform Cloud.
Thank you very much, Matthew. Let me share my screen here. Okay, hopefully you can all see the slides here. So thank you, Matthew, for that overview of Terraform and the Terraform ecosystem. So what I'm going to cover here is Terraform specifically for the Oracle Cloud, and cover where we are with the Terraform support and some of the new announcements from this week. Before I get started, I just have to make a quick safe harbor statement that while most of the content I'm going to be talking about today is generally available, anything that is forward-looking or roadmap is at Oracle's discretion to change. And of course, I can't make any commitments or statements on behalf of HashiCorp. So Terraform for the Oracle Cloud Platform and Infrastructure. So today we have support for the Oracle Cloud infrastructure components through the Oracle providers that are made available. The Oracle Cloud Infrastructure Classic provider, which has been available for quite some time, fully supports the Oracle Classic infrastructure components and Cloud at Customer, as well as the Oracle Cloud Infrastructure provider, OCI provider, which is fully supported by Oracle today And I'll touch a little bit more on the roadmap later about how we're bringing that into the certified Terraform ecosystem. But this week, we're also happy to announce the addition of the Oracle Cloud Platform provider. So really leveraging the value of Terraform's modular approach to providers to construct out different providers, support different Oracle components. The Oracle Cloud Platform provider adds additional resource support for the Oracle Database Cloud Service, Oracle Java Cloud Service. And again, from a roadmap point of view, you're going to see additional incremental capabilities and announcements coming out over time to support additional services within the Oracle Cloud Platform. What is the Oracle Platform Services? Well, Oracle PaaS is a comprehensive set of capabilities that encompasses a number of key areas, including data management components with the Oracle Database Cloud Service, MySQL Cloud, and others. The application development supporting cloud services, Java Cloud being a predominant one, as well as the application cloud, messaging cloud, and more. Integration capabilities, business intelligence, and other services not listed here for identity management, infrastructure management, and more. Let's look a little bit more at the Oracle Database Cloud Service and how the new Oracle Platform provider is able to support provisioning of database cloud services onto the Oracle Cloud. Oracle Database Cloud Service itself is an offering that enables you to easily manage and deploy single instance, clustered, or high availability Oracle database deployments within your Oracle Cloud infrastructure securely with scalability, full backup and restore capabilities, patching and monitoring of those environments. The Oracle Database Cloud Service supports exactly the same Oracle database software as is available on-premise. So software you may already be using today in your data center. You can transition directly onto the Oracle Cloud, whether you're leveraging Oracle Standard Edition, Enterprise Edition, or some of the advanced Oracle capabilities with the multi-tenant pluggable databases, all the way up to real application clustered deployments and high availability data guard. So when you provision an Oracle Database Cloud Service, what do you get under the covers? Well, whether you're provisioning from Terraform through the Oracle Cloud Console or through other tooling supporting Database Cloud, the request for an instance will automatically cover all of the underlying resource provisioning that you need, including allocating the required compute, storage, provisioning the OS, setting up the access, configuring and installing the database software and database instance configuration, setting up your backups, additional tooling, and configuring access for applications and users to that environment. By provisioning the database, By provisioning the database through these services, you get reduced time to provision, reduces a lot of the complexity in the provisioning process. It can standardize your deployment across all the instances you need to configure. And as already mentioned, this enables you to easily deploy more advanced configurations with the maximum availability architecture capabilities with real application clusters, Data Guard, Golden Gate, and others. So from a single Terraform configuration, that enables us to grow anywhere from deploying a single instance database, and then with some minor configuration changes, we can also go to a high availability rack cluster for distributed workloads. You can have high availability with Data Guard for failover in the local availability domain, and disaster recovery for failover across regions and domains. All of these can be configured very easily with just changes to the Terraform configuration. In addition to potentially deploying your production workloads with Terraform, you can also use Terraform to deploy additional database instances that are very useful in a DevOps development and QA environment and CI/CD lifecycle. So you can instantiate new instances of an Oracle Database Cloud Service from an existing database backup. And you can also instantiate new instances from snapshot clones of those instances as well. This makes it very easy and very powerful to bring up new instances of the database for developers to do testing, regression, CI/CD workflows, and then destroy those environments when they're no longer needed. Let's take a little bit closer look at the Oracle Java Cloud Service. So similar to with the Database Cloud Service, this is a fully managed environment within the Oracle Cloud. Enables you to deploy the full WebLogic application server stack, which is again, multi-tier, going anywhere from a single instance to multi-instance deployments. Built-in support for the data persistence tiers with Oracle Database Cloud and others. Elastic deployments, ability to backup and restore, patching, and cloud management. Again, whether you're provisioning the Java Cloud Service from Terraform through the UI or through other tooling, the underlying capabilities here will take control of allocating all the required compute, storage, OS, access, deploy and configure the application server software and related components, configure your backups, tooling, and provide access. Again, this enables you to reduce the time, simplifies potential complexity in the provisioning process, enables you to standardize across all your deployments, and to configure advanced configurations using Oracle Traffic Director for load balancing and coherence data grids. So if we take another look at the types of deployments we can deploy here. So again, from a single Terraform configuration file, we can deploy a single WebLogic application server, or go all the way up to a multi-node managed WebLogic cluster with Oracle Traffic Director to load balance the traffic between the different application servers, and a coherence data grid for cached data, in-memory data across the cluster. Again, we can use this in a DevOps scenario as well, so the ability to instantiate instances not just for production, but also in development and QA using snapshot clones of the existing environments in order to get existing workload data. And then finally, the real power of Terraform across all of this is the ability to combine not just the platform services together, but use those in conjunction with the Oracle Cloud Infrastructure and Infrastructure Classic compute networking and storage resources, as well as other services supported by Terraform, as Matthew mentioned, to pull together a single configuration that manages the full multi-service deployment of all dependent resources. So let's take a little bit of a closer look at exactly how to use the new Oracle Cloud Platform provider. Configuration within the Terraform configuration files starts with declaring your provider that you're going to use. You can have multiple providers declared within a single Terraform project. In this case, we're configuring the Oracle PaaS provider with the credentials for access to the environment and the endpoints required to access the database and Java Cloud services. Next, we'll declare a database instance. So using the database service instance resource, we provide some details around what this instance is, how we're going to provision it into the Oracle Cloud. In this case, an enterprise edition of 12GR2 using an hourly subscription and declaring the shape size for this instance. We can configure our access keys to get access to the provisioned underlying VM after it's deployed. And then we can configure the actual database instance running on that environment. So we set up the credentials for the database as it started. Now for this example, I've put the credentials directly in the Terraform configuration. This would not be something you do in a real deployment. You would want to bring these in from variables or use other capabilities such as HashiCorp Vault to bring in secured credentials. You can see here how we also configure some of the options on the database. So changing to a rack deployment, configuring Golden Gate, or configuring some of the data guard options is as simple as changing some of the lines here in the configuration. And finally, we want to make sure that our backups are getting persisted, so we provide the storage location where all the database backups will be provisioned to. Next, let's take a look at the Java Cloud Service instance configuration. So again, we provide some details around what this instance is, the deployment configuration with the version, whether that's standard edition, enterprise edition, or suite, the the specific version that we're deploying, our metering, and again, we can provide our SSH keys for access to the underlying VMs once they're provisioned. I'll come back to the details of the WebLogic server and traffic director configuration blocks in a second. But again, as with the database, we have the backups configured going to a location in the Oracle Cloud Object Storage. So within the Java Cloud Service configuration, we can declare how many managed servers we want within our WebLogic application server tier. We provide the credentials and the connectivity back to the database instance. And then in this scenario, because we've got multiple managed servers, we're setting up a Oracle Traffic Director load balancer to balance the traffic between those instances. So let's take a look at a demo of this actually deploying. It really is as simple as just saving your configuration file and typing Terraform apply on the command line, and everything is done for you automatically by Terraform. If we take a look at my configuration file here, you'll see I've got the same resources defined that we had in the examples shown there with the database instance and Java instance. Now, deploying these instances can take a little bit of time, and for the benefit of this demonstration, I've pre-recorded the apply phase, and I'll play this back in a little bit of a sped up way just to give you an idea of what deployment looks like. So we quickly run through and deploy the database and the Java service instance. Now, because the configuration actually declared the dependency between the Java service on the required database service, Terraform automatically knows to provision the database service first, and then once that's available, to deploy the Java Cloud Service afterwards. Just to prove that this is a real environment, let me just do a quick Terraform plan. So I deployed this previously and ran the playback, but if I run a plan here, you'll see it's going to refresh the state against the database instance and the Java instance, and all being well, we should have no changes from when I originally deployed this environment. There we go. And we can take a look at the configured attributes of those instances. Now we can go into the deployed configuration here. We have the WebLogic server running that was deployed. I can log in with the credentials that I provided. And we'll see a regular WebLogic console up and running. Just to go back and take a quick look in the Oracle Cloud Services, I'll just refresh this page. You'll see here we've got the Terraform database instance that was provisioned. We can go in and see the details here of what was configured based on that Terraform template. So we have our single instance database running. We can see the association to the Java Cloud Service that was also deployed against it. And go into the Java Cloud Service. And we see here the two application tier servers running, the load balancer, and we have full access to this environment, not just from the WebLogic console, but we can also bring up the Fusion middleware control to see the monitoring of these instances as well. Oops. Oops. Remember the password. There we go. There we go. And there we have the managed environment within Enterprise Manager. And with that, that concludes the demonstration. Just to finish up my section here, I just want to talk a little bit on the roadmap on how Oracle and HashiCorp are working together to continue to evolve and develop Oracle Cloud support within the HashiCorp ecosystem. So with the Oracle Cloud Platform Provider that we just announced this week, we will be working on additional enhancements to that to support additional capabilities around both the Java and the database cloud services. We'll have the addition of an application container cloud service resource, MySQL cloud service resource, and additional Oracle Cloud Platform services coming out over time. And certainly interested to hear feedback from the community on what would be the higher priority items for us to look at adding there. On the Oracle Cloud Infrastructure provider, as I mentioned at the beginning, we are actively working to bring the OCI provider into the HashiCorp ecosystem as a tier 1 major cloud provider. That provider is currently fully supported by Oracle and will be brought into the full HashiCorp ecosystem as well, with ongoing work to continue to add resources and enhancements as the Oracle Cloud Infrastructure continues to add new features and capabilities as well. And then the Oracle Cloud Infrastructure Classic provider, also known as the OPC provider, supports Oracle Cloud at customer deployments as well, obviously continuing to evolve and add new resources and enhancements to that provider over time based on demand as well. And finally, we are actively working to build out more examples and modules to support the Oracle Cloud. So please look for more announcements and updates on this over time. With that, that concludes my part of the presentation. Back to the HashiCorp team, and I believe we'll take Q&A.
Thank you, Matthew, and thank you, Stephen. So yes, at this time, we're going to open it up for questions. We've had a few questions coming in already. The first one I will give is for Stephen. Can you talk a little bit about what's the difference between the Oracle Database Cloud Service and the Oracle Database as a Service?
Yeah, so within the Oracle Cloud Infrastructure offering, we have a database cloud service capability directly on the Oracle Cloud Infrastructure bare metal offering. That is just on Oracle Cloud Infrastructure. With the Oracle Database Cloud Service, then you have the ability to deploy database instances not only on Oracle Cloud Infrastructure, but also Oracle Cloud Infrastructure Classic and Oracle Cloud at Customer environments as well, providing a fully managed capability within the platform services.
Stephen, on the OCI side, Terraform is being used to provision the network. Is it making changes directly to the switches, routers, or the firewalls?
Yeah, well, you're provisioning the network within the OCI environment. You're provisioning the virtual cloud network, which is the OCI cloud offering uses a virtualized networking capabilities. So you're provisioning that software-defined networking within the Oracle Cloud Infrastructure with those resources.
Excellent. Matthew, would you be able to talk a little bit about the Terraform state files?
Sure. Which piece of it? Having multiple, or?
Yeah, let's talk about having multiple providers or multiple regions.
Yeah, so when you have multiple, you can specify multiple providers in your configuration file. And so, for example, you could have your Oracle Platform Cloud and your Oracle Cloud Infrastructure Classic providers in the same configuration file, and you can just list them one after the other. And then when you call those specific resources, so for the Oracle PaaS, you'd call Oracle PaaS Resource Database Service Instance. And then just underneath that, you could have it's OPC for the Oracle Cloud Infrastructure Classic. So OPC resource IP address or storage volume or anything like that. And that's how you could have multiple providers in a single configuration.
Okay. This might be a question for both of you. Does the Terraform OCI support Chef Solo?
I don't believe so, but I guess this question back to the Terraform, the Chef provider doesn't use Chef Solo, does it? So I don't believe this for Chef Solo, unlike Oracle Cloud Infrastructure Classic, which does support Chef Solo in the OCI, in the OPC in it, which is different.
Does Terraform allow for moving an existing cloud configuration from one AD to another AD? Okay,
so with the Terraform configuration, you can target different ADs. So if you run the same configuration against a different AD, change the AD in your Terraform file, then it's going to do the same configuration in that second availability domain. If you are trying to migrate from one AD to another, then that's not necessarily going to give you exactly what you wanted. If you just change your Terraform configuration, it will destroy all the instances in the original availability domain and recreate them in the second availability domain. So if you are worried about the persistence of any information that was in that original deployment, then you need to take a different approach to maybe bring up the second domain and then do a migration of any data between them. Now, if you've got database instances, that could be by saving the backups and then reinstantiating from backup. And there are other options and capabilities to migrate application workloads from one domain to another.
Thank you. And just another question, just a little bit, backtracking a little bit. Could you explain a little bit of the difference between the various offerings from Oracle, so Oracle Public Cloud versus Oracle Cloud Infrastructure or OCI Classic? So we just had some questions about the different abbreviations and understanding some of the differences between the different offerings.
Sure, yeah. So when Oracle first launched the infrastructure capabilities, it was launched under the brand of Oracle Public Cloud. Those capabilities, those cloud environments support a number of regions globally throughout the world. Then with the introduction of a service that was called the Oracle Bare Metal Cloud Service about 2.5 years ago, that is a brand new cloud architecture offering developed by Oracle using the latest in terms of both the virtualized hardware capabilities and data center architectures with leaf and spine, multi-availability domain. So that is what we originally called the Bare Metal Cloud, and about 18 months ago was rebranded as just Oracle Cloud Infrastructure. So you may see the two terms used synonymously with Bare Metal and OCI. So those are that's the newer Oracle Cloud Infrastructure that is being deployed globally. Meanwhile, the original deployments, the Oracle Public Cloud, as it was called, now called Oracle Cloud Infrastructure Classic, continues to be a fully supported capability and is the underlying technology used for the Oracle Cloud at Customer that enables you to deploy Oracle Cloud within your data center as a fully managed cloud environment connected to the public cloud. So to kind of round it out, we have the Oracle Cloud Infrastructure Classic, the original Oracle Cloud Infrastructure. We have Oracle Cloud Infrastructure with the bare metal and virtualized capabilities using the latest modern cloud technologies, data center technologies. And then Oracle Cloud Platform with the database cloud, Java cloud, and others is really agnostic of the underlying infrastructure that it's running on. So you can deploy those services to either Oracle Cloud Infrastructure, bare metal, or virtualized, or to Oracle Cloud Infrastructure Classic or Cloud at Customer. I hope that helps.
Absolutely. And then this is another Oracle question for you, Stephen. Is Terraform interacting with the PSM CLI for Oracle Cloud Pass? And can you explain a little bit about how these tools should be used together? And does Terraform replace the need for PSM for those provisionings?
Okay, so PSM and Terraform both use the same underlying APIs. So it's the same provisioning process that PSM uses, but it doesn't directly use PSM CLI. So there's a lot of similarities between the Terraform support and the PSM support because it's using the same underlying capabilities through the individual service APIs. The two can be used in conjunction. It really depends what you're trying to achieve. You can deploy your services with Terraform, and then you can use PSM or the UI to make some updates, management capabilities, so you can trigger your backups through PSM, trigger your snapshots through PSM. Those kind of more interaction type activities that are not part of just the original infrastructure provisioning or modification, then PSM would be a very useful tool to use.
Thank you. Matthew, and then also Stephen, you may have some input on this as well. We had a question about, is there an easy way to deploy the same infrastructure to different environments? So like dev, staging, production, just by passing a variable and skipping parts of deployment, as it's only applicable to production or staging?
Yeah, so this, you can do this, but it's not a best practice. It's really risky to do such a thing, especially if you're keeping the state files within the same kind of folder structure in the same directory. And so you can use different workspaces pointing to the same repo, and then different branches to ensure that isolation. And then it's also best, like I said, to keep your state files separate. And then you might find a lot of success by using modules with this, where you can kind of specify, have the same configuration, but just have a different environment variable that you can kind of toggle, where, like you said, like with dev, CI, QA, that kind of thing.
Thank you, and we'll take a couple more here. A lot of active questions, so appreciate the feedback from the audience. Stephen, is the functionality the same between PSM and Oracle Terraform provider? And can you deploy with PSM, or can it be deployed via Terraform?
If you deployed via PSM, you would have to then import that into Terraform. That's a capability that's not in the initial release of the platform provider. The import is something that we have on the roadmap to add. You can also deploy with PSM and use the data source for the database, for example, to bring a PSM deployed instance into your configuration without necessarily managing it from your configuration. So if you need to bring in data attributes about that particular instance for use with other resources that you're configuring and deploying, then the data source is a useful way to do that. But other than that, I mean, if you're actually trying to manage the life cycle of an instance, then you want to pick one tool and use that tool only. Otherwise, you're going to get into situations where you may be applying conflicting changes. So if you destroyed the database through PSM and then rerun Terraform, it's going to say it went away and try to recreate it, or vice versa. So.
Excellent, thank you. Okay. And since we've had so many questions, if you both could just give a quick summary of where our listeners could go to find additional information that maybe we haven't covered yet today.
Sure. So for the Oracle PaaS provider, you can find that on GitHub. So any issues that you have, or any feedback, you can post through the issues through GitHub, so we can kind of take that information and fix whatever issues you have, or kind of help you, guide you through the use of the provider.
Yep. As Matthew said, the GitHub repository is a very much a key location to find information. Also, there's a number of blogs and articles out on blogs.oracle.com/developers. You can also look for articles by me on Medium in the Oracle Devs publication around the use of both the OCI Classic providers, and you'll find more coming out around our platform support as well. In addition, there is a Terraform examples repository on the Oracle GitHub. So github.com/oracle/Terraform examples. You'll find plenty of links to examples for the classic OCI and the platform services there. And feel free to contact me directly for anyone that wants to find out more.
Excellent. Thank you both. I just want to thank you, Matthew and Stephen. We had some great questions from the audience, a lot of interest in this topic. I do hope that everybody enjoyed today's webinar and have a better understanding of how Terraform and Oracle Cloud work together. As you can see, there's a large roadmap of cooperation between the two companies. I want to thank you all for joining, and I want to give a big thank you to Matthew and Stephen for their time today. I also wanted to mention that HashiCorp is hiring. So if you like what you heard today, please take a look at our jobs page, hashicorp.com/jobs, and see if there might be a fit for you. And finally, as we mentioned at the beginning of this webinar, it was recorded, and we will be making a recording available on our website after post-processing, typically within 1 to 2 days. And I will send an email for everyone who registered with a recording link. You can also keep your eyes out on Twitter, where the recording link will be made available as well. And I wanted to say that everybody have a great day. Goodbye, everyone.